Welcome everyone to the first part of the Python Crash course. Before we go to the Jupyter Notebook and actually code through some of this stuff, I want to quickly discuss what we're actually going to be covering. We'll talk about the fundamental data types, things like numbers, strings, dictionaries, etc. We'll discuss comparison and logical operators in Python. We'll talk about control flow statements, things like if, elif, else statements, for loops, and while loops. Then we'll discuss functions, how to create your own, some built-in functions, and then we'll also talk about some few built-in Python expressions. Okay, let's open up a new Jupyter Notebook and get started. Alright, here I am at a Jupyter Notebook. The very first thing I want to discuss is how you can comment your code. To create a single line comment, just do a hashtag, type comment, and then you'll notice if I run this cell with Shift Enter, I don't get anything back. So if I actually want to see something back, I can enter like a number, 10. I'll do Shift Enter, and I can see my output is just 10. If I don't want to actually see this or have it run, I can comment it out. Now I don't get any output. Okay, let's start off with just discussing simple numbers. So numbers are quite easy to work with in Python. Addition is just a plus sign. If you want to do subtraction, it's just 1 minus 3. Multiplication is just something with an asterisk. So 2 times 3 is 2 asterisk 3. If you want to do division, it's just a forward slash, 1 divided by 2. And I'm doing spaces here, but just so you know, you don't actually need those spaces. It'll work either way. If you want to do exponents, it's just 2 asterisk signs in a row, 2 to the power of 4. That's 16. If you want to do the mod operator, that is get the remainder of a division, it's the percent sign. So let me show you that real quick. So if we do 4 mod 2, that should return 0. So what this is actually returning is the remainder component. So 4 divided by 2 goes in evenly twice with remainder 0. Now if I do 5 divided by 2, that will end up being 2.5. So 2 goes into 5 twice, and then it has a remainder of 1. Otherwise known as 1 over 2, which is 0.5. If I actually just want to get that whole remainder value, I could just do something like 5 mod 2, and that would return the remainder 1. So 5 divided by 2 is 2 remainder 1. Alright, and then lastly, you can actually specify order of operations in Python. So if you were to do something like 2 plus 3 multiplied by 5 plus 5, this would actually end up multiplying 3 and 5 first, and then add 2 and 5 together. If you want to specify for the addition to happen first, you can just do parentheses. So it can say parentheses 2 plus 3 multiplied by 5 plus 5. And now if you run that, you get 50. Okay, so that's the very basics of numbers. Hopefully that was pretty straightforward. Now let's quickly discuss variable assignments. So in Python, your variable assignments are going to just pretty much always be lowercase and follow snake casing. That means the name of the variable, as far as separated words, are going to be separated by underscores. So we'll have some name of the variable, and then we just use the equal sign for assignment, and we'll set that to 2. For example, I can say x is 1, and y is equal to 2, and then I can do something like x plus y, and get it equal to 3. Or I could set a new variable, z is equal to x plus y, and then ask for z back out, and I get 3. That's the basics of variable assignment. Moving on to another fundamental data type, strings. Strings can either have single quotes or double quotes. So we can have single quotes as a string, and then I can have double quotes as a strings. So notice that when I actually ask for the string to be returned, the default is just to have it as a single quote. Either way, it's pretty much the same thing. The reason we have the option of both single quotes and double quotes is in case you want to wrap a single quote. So for example, in case you want to say something like, I don't care, without getting some sort of unfinished string error because there's a single quote there, I'll just wrap it in the other quote type, which is double quotes. And here we can see we don't actually get an error there. And it says, oh, this single quote isn't actually a string quote because it's wrapping it in double quotes. Okay, now let's discuss actually printing out strings. So you can see here that the strings are just being returned, they're not actually being printed out. So in order to print things out, all you need to do is use the print function. So if I have a variable x, and I have it equal to hello, and I ask to print x, notice I just get back hello. And the way the Jupyter Notebook works is it denotes printing by not actually reporting that it's a string with quotes, and it also doesn't report an output cell. It just prints out whatever you said to print out. So likewise, I could say something like print double, and it will just print out the word double, no quotes, and no output cell there. Then I want to talk about print formatting. Sometimes it's known as string interpolation, where you want to insert a variable into a string when you're printing it out. So for example, if I wanted to say my name is Jose Portilla, and I'm going to print out, hello, my name is, and somehow I want to insert this variable called name into this print function or print statement. The way I can do that is I input these curly braces, and then at the end of the string I call a .format method, and then I pass in the variable name. So then when I run this, what's going to happen is Python is going to look for the variable name, which I've already defined up here as Jose Portilla, and then it's going to insert it into these curly braces. Now this can actually get a little more complex, so let's go ahead and define another variable. We'll say defining a number value, or a number variable, and we'll call this number, let's say 12. And then what I'm going to do now is print, hi, my name is curly braces, and my number is curly braces. Then we're going to say .format, and then I'm actually going to insert not just the name, but also that number variable. Then if I run this, it says, hi, my name is Jose Portilla, and my number is 12. We can continue to actually expand on this by giving these two some local temporary variable names. So I can say something like x is equal to name, and y is equal to number here. And then inside these braces, I can say x and y. And then when I run this, I get the same result. But what's nice about doing this sort of local variable assignment is then I can not have to worry about the order that I pass them into the format method. I can say yy, and this is going to say, hi, my name is 12, my number is 12. Or I could reverse the order and say, hi, my name is 12, and my number is Jose Portilla. So this is a nice little trick to use this variable name, this local one, inside your string. And that's the basics of string interpolation and print formatting statements. Okay, let's move on to lists. Lists are basically Python's form of an array. So the way you define a list, and I'm just going to comment here what we're talking about, a list, is you have square braces or square brackets, and then you separate out the items with a comma. So that's a basic list. Keep in mind, a list can actually hold multiple data types, so you can hold a string here, and it can hold numbers, and it won't actually complain. And the other thing to note is that you don't need to predefine how long a list is going to be beforehand. It's a dynamic array, and you can just keep adding stuff to the list. So let's create a list called 1, 2, 3. Well, I'm actually creating a variable called myList, which consists of a list of 1, 2, 3. I'm going to run that. And now if I actually want to add an item to this list, I can say myList.append, and I call this append method on the list, and then I'm just going to type in what I actually want to append. Let's say the number 4. Or in this case, yeah, the number 4, not a string called 4. Then if I return or ask for my list, it returns back 1, 2, 3, 4. So the way you can add an item to the end of a list is just with .append. If you want to index an item off of a list, indexing starts at 0. So let's redefine our list to be A, B, and C. Let's add one more letter in there, D. So if I ask for my list, and you can use tab to quickly auto-complete this, you'll get back A, B, C, D. If I want to grab the element A, what I end up doing is using indexing. I can say square brackets off the variable list, and then pass in its index location. And indexing in Python starts at 0. So we'll say 0 there, we'll run that, and then we get back A. If I want to grab the letter D, there's actually two ways I can do that. One way is just counting over 0, 1, 2, 3. So I could pass in 3, and that returns D. But Python actually supports negative indexing, means I could say -1, and that will automatically return the last element of a list. So starting at 0, it goes backwards 1 towards the end of the list, and that also returns D. Alright, now let's quickly discuss slicing a list. So right now we can use indexing to just grab a single item off of a list. But if I want to actually grab multiple items that are together, remember this is a sequence that's ordered, so 0, 1, 2, 3. Let's say I want to grab A and B, what I can end up doing is say the starting position at 0, and then colon, and then we add in up to but not including the last position. So if I want A and B, that's going to start at 0 and then go up to but not including index 2. So if I run this, I then get back A and B. So this is a little confusing for beginners at first who aren't used to this sort of notation of indexing at 0, in case you're coming in from another language such as, I believe MATLAB starts indexing at 1. But sometimes people expect this to say A, B, C. The thing to remember here is that the first one starts at that index, colon, up to but not including that index. So I can zoom in one more time. We see list A, B, C, and then 0, colon, 2 returns 0, 1, and then up to but not including 2. Okay, if you want to do everything in the beginning, a shorthand for that is to say colon 2, and that will return the same thing. You can otherwise do the reverse and say starting at index 2, colon, give me everything to the end. And that will be CD. So remember, this first index does get included, and then if you're adding in a last index, it's going to be up to but not including that. And then finally, you can have a nested list. So I'm going to create a variable called nested, and I'll set this equal to 1, 2, and then as the third item in this list at index 2, I'm going to have another list of AB. So notice the double sets of brackets here. So if I call nested, that's a nested list. If I want to grab the letter A, what I have to do is say, okay, 0, 1, 2. So I pass in 2 here, run this cell, and now I have that list that was at position 2. Then I can add in another set of indices, which is going to now grab A. So it's going to be at 0 of this list. And that's how I can grab A by itself. And that's how you can use a nested list. Okay, so now let's discuss dictionaries. Dictionaries are a hash table, as it is known in other languages for Python, and it essentially consists of a key value pair or a key item pair. The notation for a dictionary ends up using curly braces, so I'm going to create a dictionary called D as the variable name. I'm going to have curly braces here, and you have some sort of key as a string, colon, and then some value, such as a number, 10. And then if you want another key value pair, you'll add in a comma, you'll have some other key, we'll say this is key 2, and then you can have some other item corresponding to key 2. Let's say second item as a string. So now the thing to remember about a dictionary is that a dictionary does not actually retain any sort of order. Instead, it's acting as a hash table, where instead of storing things as a sequence of items in a particular order, it stores them as key value pairs. So it has this key and then a value. So if you actually want to grab a value or item from a dictionary, what you end up doing is saying D, square braces, and then you pass in the key. Unlike a list where you pass in an index position, for that dictionary it doesn't really make sense because it's unordered. So what we end up doing is just passing in a key. So if I want to grab the string second item, I just pass in key 2. Run this, and that returns second item. And that's the way a dictionary really works. It's just key item pair, essentially operating like a hash table in other languages. For Booleans, that is true and false in Python, it's just going to be true, capital T, everything else lowercase, and false, capital F, everything else lowercase. There's a few more data types that we're going to discuss, and that's tuples and sets, and that will finish our discussion of the fundamental data types of Python. Tuples are really similar to lists, except instead of square braces, they end up using parentheses. So we can see here I have a tuple. Some people also call them tuples. So we have a tuple or tuple consisting of 3 elements, 1, 2, 3. And I can index these just like I could with a normal list. It returns back 1. Now, if I have a list and I set it equal to 1, 2, 3, and I indexed it the exact same way, I get back the same result as a tuple or a tuple. So you may be wondering, well, what's the difference between this tuple and this list? Well, a tuple is immutable, meaning you can't actually change an item once it's in there. A list is mutable, meaning you can mutate it and actually change items. So let me show you an example of the list versus this tuple object. So I can say grab my list, element at 0, and set that equal to the string new. So if I call back my list, I get back new 2, 3 instead of 1, 2, 3. So I can see that this list object is mutable. If I try to do the same thing with this tuple, remember a tuple is defined by those parentheses, I can get t0, set it equal to something that's new, I'm actually going to get an error. And the error is going to say this tuple object does not support item assignment. So a tuple is immutable, meaning you can't do this sort of reassignment. Now the reason for that is because sometimes you're going to want to store data in a format where you don't want a user or your program to later on have access and switch things out. And you usually want to reserve this for things that shouldn't be changed. Maybe, for example, the days of a calendar. Those are going to be the same no matter what you're doing, so you probably want to store those as a tuple in order to not really mess around with things later on in your program. As you program more and more with Python, it'll become more obvious where a tuple is a good choice versus a list is a good choice versus a dictionary. But at now, you should just be aware of the various data types. And the final data type we're going to discuss is a set. A set is an unordered collection of unique items. And that kind of looks like a dictionary in that it does use curly braces, but you just pass in the items themselves. There's no key item value pairs here. Now the thing to remember about a set, it's that an unordered collection of unique items. What that basically means is if you pass in multiples of the same item or element, when you run this set, it's only going to grab the unique instances, meaning it's only going to grab one of one, one of two, and one of three. So what's nice about this is you can use the keyword set, pass it in a list that has multiple elements here, run this, and you'll get back a set of the unique elements. And that basically concludes our discussion of the fundamental data types of Python. So remember, we started out with numbers and did some simple arithmetic and math. And as a quick note, in case you ever want to do some more complicated math than what we showed here, I'm going to put a new cell here, you can actually import the math library. And this math library actually comes with a lot of abilities. So you can say math dot, in the Jupyter Notebook, you can hit tab, and it will show you various mathematical functions that are available. So Python is sometimes called a language that comes with batteries included because this math library is already built into Python. Now we'll talk a lot more about importing other libraries that we're going to be using, such as pandas, numpy, matplotlib, etc. But things like basic math, that's actually already included. So for example, if you want to take the square root of something, you could say math.square root. And then if you wanted to find out more about this, you can do shift tab, and it will report back this documentation string, which is return the square root of x. And we'll talk about the documentation string later on when we discuss functions in this crash course. For example, square root of 10, enter that, we get back 3.16, etc. So that was the basics of numbers and arithmetic. Then we discussed variable assignment. Then we also discussed strings, how we can use single quotes and double quotes. And as a quick note about strings, for instance, I have x is equal to hello here. I can use the same indexing we used on a list on a string. So if I wanted to grab the very first letter, such as h, I could say x of 0, and that'll return h. So what you should do, in order to get a little bit of practice with indexing, is try to create a string, such as y is equal to hello world, and then say, try to grab a random letter. So see if you can grab this r, for instance. All you have to do is count over 0, 1, 2, 3, 4, 5, 6, 7, 8, pass in 8, and there you get r. Then we learned about print, string interpolation, lists, basic arrays. We learned about nested lists and how you can grab stuff from a nested list. We learned about slicing, this nested, this various bracket notation, dictionaries, booleans, tuples, and sets. All right, thank you everyone, and we'll continue this along in the next lecture where we will be discussing control flow and functions. I'll see you there.